Hello, my 6th and 7th period. I apologize, I have a doctor's appointment, but I have created a cute little video for you so that you don't miss the beginning of lesson 5.6. All for one, one for all. It starts with a jump start and it goes through all the constraints that Carlos and Clarita have identified for their pet sitting business. Their first one that we've talked about is the startup costs. They have $1,280 to invest. It costs $32 for each cat pen and $80 for each dog run. So that's right what that inequality looks like. So that would be 32x plus 80y less than or equal to 1280. Okay, and then our second constraint was space. Cat pens need 6 square feet. Dog runs need 24 square feet. Carlos and Clarita have up to 360. So our space constraint as an inequality is 6x plus 24y less than or equal to 360. Okay. In the last lesson, we learned about 2 more constraints. These were on time, right? Feeding time and pampering time. So for feeding time, they've estimated that cats require 6 minutes a day, morning and evening, to feed and clean their litter boxes for a total of 12 minutes per day. So 6 minutes twice a day, so 12 minutes per day. So that'll be 12x plus. Dogs will require 10 minutes twice a day for a total of 20 minutes per day. So 20y. And Carlos can spend up to 8 hours each day for the morning and evening feedings, but needs the middle of the day for baseball practice and games. So remember, we needed to convert the 8 hours to minutes. So 60 times 8. We got less than or equal to 480. Okay. And then our fourth constraint was pampering time. The twins plan to spend 16 minutes each day brushing and petting each cat. So that'll be 16x plus 20 minutes each day bathing and playing with each dog. So 20y. Clarita needs time off in the morning for swim team and evening for her art class, but she can spend up to 8 hours during the middle of the day. So remember, we got to change the 8 hours to minutes. So that'll be less than or equal to 480. Okay, so those are our 4 constraints written as inequalities. So it's all coming together, right? All right, let's go ahead and turn the page. Carlos and Clarita have found a way to represent combinations of cats and dogs that satisfy each of their individual pet sitter constraints, but they realize that they need to find combinations that satisfy all of the constraints simultaneously. Why? Since these are all constraints, right? These are limitations on their time, money, or space. They all need to be satisfied at the same time in order to work. So let's list our first 2, right? The startup costs and the pet constraint. So startup cost was 32x plus 80y less than or equal to 1280. And then the space was, there we go, 6x plus 24y less than or equal to 360. And then task 2 has a shader region on the coordinate grid that would represent the solution set for the system of inequalities. So now we're calling this a system of inequalities. Remember, a system is just 2 or more equations or inequalities solved at the same time. Explain how you found the region to shade. All right, we're gonna need colored pencils, right? Or markers, something. We're gonna make this graph colorful. Before we do that, though, we need to find our x and y intercepts in order to easily graph these. So we're just going to do a really quick review on how to find x and y intercepts. So I'm going to say x intercept and y intercept. Okay, just a reminder how to find intercepts. You divide your total, right? So I'm going to do the cost constraint. You divide your total, 1280, divided by the number in front of the x. That will be the x-intercept. So my x-intercept is 40, 0. And then to find your y-intercept, it's going to be the total, 1280, divided by the number in front of the y, divided by 80. So this is going to be our y-intercept, 0, 16. Okay. And I'm going to like this. Okay, now let's do our second one. So to find our x-intercept for the space constraint, we're going to do 360 divided by the number in front of x. So we get 60, 0. And to find our y-intercept, it's going to be the total, 360, divided by the number in front of y. So that is 0, 15. Right, so now we've got all our intercepts, and we're going to use them to graph. Okay, and we're going to make this colorful because we want it to really see what's going on. So I think I'm going to graph my my money constraint using red. So let's go here to an x-intercept of 40. We're going to put a point there. And then the y-intercept is 16. So let me put a point here. And then we're going to connect those. Okay, I think I could have done better. Let's try one more time. There we go, that's better. And then we're going to shade where we have solutions, right, to the startup cost constraints. So that's all this down here. Okay, so that one is done. I'm going to switch colors, so I'm hoping you're going to switch colors too. I'm going to switch to blue for our space constraint. So I've got 60 as my x-intercept, so right there. 60, and then I've got, what was it, 15 as my y-intercept right there. I'm going to zoom out a little bit so I can see them both, and then hopefully draw a nice line in between. There we go. Okay, and then I'm going to shade, right? Let's do my shading right there. I'm going to shade below that blue line. To see all my possible combinations of cats and dogs that would satisfy space. All right. Okay, almost done. Just to do a little bit more coloring here on the right. Okay, awesome. All right. Explain how you found the region to shade. Shade a region on the coordinate that would represent the solution set for the system of inequalities. Ooh, so I shaded under each individually, but there's actually a region that satisfies both inequalities. So I'm going to do a third shading just for that region. It's called a feasible region. So do you see here at 15? I'm going to shade below that. And then where the point of intersection is, I'm going to follow the red line down. And then this is the zone that satisfies both constraints. Okay. So you'll see that there's a little triangle upper left corner that only satisfies the red constraint. What was my red constraint? I think that one was cost, startup cost, right? Here I should probably write what each of them are. Okay, so the red was cost, and the blue was space. That way I can keep track of what the lines, boundary lines mean. So you can see that there's a little triangle here, upper left, that satisfies the cost, but not the space. And then over here on the right, you can see that there's a little triangle. Well, not a little triangle. It's quite big. Look, it's really big. And it's not to, it's one, yeah, that just satisfies space. Okay, so we've got like 4 zones actually showing up. So I'm going to actually label their colors so that we can talk about them. So we've got this green zone here, right? That's kind of important, this green zone. We've got this red zone over here. This little can't see that very well, can we? So red area right there, red region. It's just a little triangle. We've got this really big blue triangle, okay? And then we've actually have a 4th area, and it is this white space over here, right? So we've got red, blue, green, and white. 4 different regions showed up, 4 different areas. All right. So explain how you found the region to shade. So the region to shade for the solution was this green region, right? That's where we have double shading going on, right? That's where the red shading and the blue shading overlapped. Okay, so I'm going to say that where red and blue shading overlapped. Okay. So that is a super important zone, and I'm gonna even outline it in like this green just to show in detail where we've got our double overlap. All right, task 2. Find at least 3 combinations of cat and dog that would satisfy both of the constraints represented by this system of inequalities. How do you know these combinations work? All right, so I'm going to just visually choose 3 combinations of cats and dogs that I know satisfy both of these constraints. And I'm going to choose them in the green shaded, right? That's where we've got red overlapping with blue. Okay, so I'm going to choose, let's say 15, 5, and let's do 5, 10, and let's do 10, 10. Okay, so 15, 5, 5, 10, and 10, 10. And we are going to make sure I chose wisely, like visually. I think I chose wisely, but we do need to verify that both constraints are satisfied. So for cost, it has to be less than or equal to 1280, right? And for space, we have to have less than or equal to 360 square feet of space. So I'm going to break out my calculator and fill in these numbers. So cats cost $32, so 32 times 15 plus dogs cost 80, 80 times 5. So the cost for this first combination was $880. Right, I'm just using 32x plus 80y, and I'm replacing the x and y with the the number of cats and dogs, right? Cats is x, dogs is y. All right, let's figure out the cost for 5 cats and 10 dogs. So we go 32 times 5 plus 80 times 10. So that's 960. Okay, and then let's do 10 cats and 10 dogs. 32 times 10 plus 80 times 10. 1120. So all of those work, right? These all are under the cost constraint. Now let's verify that the space constraint is satisfied. So remember that 6x plus 24y has to be less than or equal to 360. So let's find our first one for 15 cats and 5 dogs. So we go 6 times 15 plus 24 times 5. So that's 210 square feet. Then 5 cats and 10 dogs. So that's 6 times 5 plus 24 times 10. So that's 270 square feet. And then we'll do 6 times 10 plus 24 times 10 for 10 cats and 10 dogs. And that's 300. Okay, we double checked. How do you know these combinations work? There's 2 reasons we know they work, right? All are under 1280 and under 360. So that's our first reason. And then all are in the double shaded region. Okay, so we've got 2 reasons. Mathematical one in our table we verified, and also visual one. In our graph, visually we saw where it was located. All right, number 3. Find at least 3 combinations of cats and dogs that would satisfy one of the constraints but not the other. Oh, interesting. For each combination, explain how you know it works for one of the inequalities but not for the other. All right, so I cannot choose things in the double shaded region for number 3 because that would satisfy both, but we only want one of them satisfied and not the other. Okay, so let's go and visually choose some. So I'm going to go up here. So the zones that I want to choose from are not green, right? We're not going to choose from the green. We're not going to choose from the white. In white, neither constraint is satisfied. We want to choose in the red or the blue, because in the red or the blue, one of the constraints is satisfied. So let's go over here. Let's go to the red, and I'm going to choose right here 1 comma 15. So that will be my first choice. Okay, and we'll show the numbers of that in a moment, but let's visually choose 2 more. So I chose 1 in the red. Let's choose 2 in the blue. So how about like 35.5 and 43. So 35.5 and then 43. and 3. Okay, so let's figure out those costs and those space. So this has to be less than or equal to 1280. Just a reminder, this has to be less than or equal to 360. This is 32x plus 80y. This is 6x plus 24y, right? Okay, let's get our calculator out. So for cost, for 1 cat and 15 dogs, I'm going to go 32 times 1 plus 80 times 15. So that is 1,232. Okay, let's do our next one. 35 cats and 5 dogs. So 32 times 35 plus 80 times 5. So that's 1520. Okay, and then 40 cats. So 32 times 40 plus 80 times 3. So that's 1520 as well. Interesting. So immediately we see that this first combination of cats and dogs totally satisfied the cost. It didn't go over 1280. It was fine. But these next two broke the budget, right? They went over 1280. So those next two did not work. All right, now let's figure out for space which of those combinations work or don't work. So let's do 6 times 1 cat plus 24 times 15 dogs. So that's 366 square feet. Does not work, right? That's more than 360. And then we go 6 times 35 plus 24 times 5 for the next one. 330 square feet. That was fine. And then last one, 6 times 40 plus 24 times 3 gets us 312. So that one was fine. So remember, both constraints need to be satisfied for a combination to be a solution. And you can see right here that that this combination right here is broken for cost. This combination right here is broken for cost, and this one right here is broken as far as space. Okay. For each combination, explain how you know it works for one of the inequalities but not for the other. Okay, so we can write a little comment off to the side and say, does not satisfy space, doesn't. You could write satisfy or work for space, work for space. These two don't work for cost. Okay. And that is as far as I'm expecting all my morning classes to get on this lesson. So you guys will be caught up, even though I wasn't there to help teach this live. All right, we're going to end our notes now. And tomorrow we will pick up on the next task in this lesson. All right, we'll see you tomorrow. Bye.